Okay, everyone, today we are going to be starting Lesson 11. But before we begin, I just wanted to go over a few things that Mr. Kate went over with you yesterday. Remember, he talked about cylinders, and the volume of a cylinder would be pi radius squared times your height. And the formula for volume of a cone is 1/3 pi times your radius squared times your height. So please remember this, and those two formulas right here will be on the formula sheet that we will give you for the test and that you will use during your PSSAs as well. So you do not need to memorize those formulas. So today we're going to talk about volumes of a sphere, and this starts on page 54 in your book. And just recall that a sphere is a perfectly round geometric object in a three-dimensional space. So here we have a basketball, baseballs, ping pong balls, anything that is a perfectly round geometric object in a three-dimensional space. If you would turn your page now, we're going to try to do some examples. So this first example is on page 55 in your book. It's example 1. I'm just going to give you the formula for volume of a sphere. The formula is 4/3 times pi times your radius to the third power. The big thing you have to make sure is you always plug in your radius. Remember, your radius is only halfway. Your diameter is the entire way. So remember, if they give you your diameter, to find your radius, you take your diameter and divide it by 2 or cut it in half. So for this very first problem, we're going to write down the formula. V equals 4/3 pi r cubed. Here they give me my radius, which is 4, so I'm going to plug that in. V equals 4/3 times pi times your radius, which was 4, all to the third power. If you plug this exactly in your calculator as you see it here, you should get an answer of either 256 pi over 3, or if you don't want to include the pi symbol with it, remember you press the arrow key, which is in the bottom right corner of your calculator, and you would get an answer of roughly 268 cubic centimeters. Make sure you label. My label is centimeters, and volume is always to the third power. So either one of these answers would work. Sometimes on your test you're going to have to leave it in terms of pi. Sometimes on your test we want you to not leave it in terms of pi, just get to the actual numerical value. So make sure you know to switch back and forth between the pi answer or this answer. You use that arrow key. And if you're unsure of where that's at, make sure you ask your teacher at this time or when you get to class the next day. Here is another example. So of course we are going to write down our formula, 4/3 pi r cubed. Here they are telling me that my radius is 6, so I'm going to plug that in. 4/3 times pi times 6 to the third power. You plug that exactly in your calculator as you see it. You would get either 288 pi, or remember to switch to the other form, press that arrow key, and you would get roughly 905. My label is in inches, but since it's volume, you have to raise it to the third power because it's three-dimensional. Either one of these answers would work, and I want you to put both down at the moment. Let's try this one. So here we have a basketball, and it gives me my diameter. But remember my formula, 4/3 pi r cubed. My formula deals with my radius. So remember, in order to find your radius, you take your diameter and divide it by 2. So I would plug in 9.5 and divide it by 2, and I would get 4.75. So now I can plug that in for my radius. So I would have V equals 4/3 pi times 4.75 to the third power. Plug this exactly in your calculator as you see it, and you would get an answer for your volume of 142.9 pi, or remember, if you press your arrow key, the other form without the pi would be 448.9. I rounded to my tenths place because that's what the problem stated, so make sure you do that, and you know that that would be for 1 decimal. Also, my label is in inches, so make sure you label cubic inches, which is just your inches to the 3rd power. Make sure you supply both answers on a test, unless it asks you specifically for one of them. So here we have a spherical fish tank, and we have a radius of 8. So I can just use my formula, 4/3 pi r cubed. So I have 4/3 pi. My radius was 8, so I'm going to plug in 8 cubed. And they want us to round to the tenths place, which means 1 decimal. So if I plug that all in my calculator, and you should try this on your own, you should get 682.7 pi, or if you press that arrow key, you would get 2,144.7. I'm dealing with inches, so make sure you label cubic inches. The volume is always to the 3rd power because it's 3-dimensional. Okay, so for number 7, they want you to predict which of the figures shown above has the greater volume. So right now, just make a prediction. Do you think it would be the cone or the cylinder? And you are going to write your prediction right here. So put your prediction down, whatever you think it is, and make sure you explain. So now for part B, they actually want you to find the volume of each and determine which has a greater volume. So I would actually like you to try this one on your own. I want you to find the volume of the cone, and remember the formula is V equals 1/3 pi radius squared times your height. And the volume of the sphere, the formula is 4/3 pi r cubed. So using the information they have there, I want you to try part B, finding the volume of each on your own and stating which diagram would be larger, or which shape would be larger. So pause your video, and when you're ready to check your answer on part B, press play. So you can start checking your answer. And as you would see, my cone, I plugged in my radius and my height and got an answer of 26.25 pi cubic milliliters, or 82.5 cubic milliliters, depending on if you use the pi form or not. And for the sphere, when I plugged 2 in for my radius, my volume is 29.3 pi cubic milliliters, or 92 cubic milliliters. So if we compare, it asks which has a greater volume. Well, obviously, it would be the sphere, because 92 is larger than 82.5. So the sphere is the larger shape. So like I said, all you are doing is just comparing your volumes. Plug them into the formula and compare. So this is number 8 in your book on page 59. One of the 2 half spheres formed by a plane through the sphere center is called a hemisphere. So sometimes they're going to give you questions about hemispheres. What is the formula for the volume of a hemisphere? So basically, a hemisphere is half of a sphere. So you are going to do the same thing when it gives you a hemisphere question. You could use your original formula, 4/3 pi r cubed, and then, since it's half of a sphere, just divide it in 2. So once you get your answer for this, just divide it by 2. Or some kids like to think of it this way, that they take half of the formula for the volume of the whole sphere. Either one of these equations would work. I tend to use this one because I get my answer the way I normally would and then just divide it by 2. But it's totally your call. We're going to actually try one of these. So at the bottom of that page, I want you to try this example for me. So let's say here's my lovely hemisphere. It's so beautiful. And I'm going to tell you that my diameter is 4 meters. So I want to find the volume of that. First, here's my formula for volume of a whole sphere. Remember, I need to find my radius. So it tells me that my diameter is 4. So to find my radius, remember, I have to divide it by 2 or cut it in half. So 4 divided by 2 would give me 2. So that is my radius. If I plug it into my formula, I would get 4/3 pi times 2 to the 3rd power. In my calculator, I would get 33.5. But that's if I had a whole sphere. I only have half of a sphere, which is called a hemisphere. So once I get that, all I have to do is divide it by 2, and I would get an answer of 16.8 cubic, whoops, I wrote too many M's, 16.8 cubic meters. Remember, all I did was plug it in as if it was a whole sphere, and then once I got that answer, I just divided it by 2 to give me half of the sphere, which is my hemisphere. So I hope this information has helped you find the volume of a sphere, or on this page, like we did, a hemisphere, which is half the sphere. You can always put a star beside anything that you were confused on, and make sure to ask your teacher, and we will go from there. Thank you so much, and have a wonderful day.